Hey guys, so jumping right into today's lesson, we will be using the whiteboard again. You're going to need your notebooks, and what you're going to be doing is taking notes in Cornell Notes format on hierarchical relationships in our universe. This is a two-part lesson. I'm going to start with hierarchical relationships, and then after that I'm going to jump into kind of a brief overview of our terrestrial planets and our gas giants and the major differences between them, and then you guys will be classifying them in your notebooks. So let's jump right into it. Here we go. So much like last week, I'll be using the whiteboard today. I have taken a separate picture of it. Thank you for that feedback so that you guys have it. So if I went too fast or if there's anything else that you need to get from it, you certainly can. So here we go. So today I'm going to be discussing the hierarchical relationships in the universe. The word hierarchical comes from the word hierarchy. We use this very often when we're talking about rank, or when we're talking about the king is the top, and then the queen might be right underneath, and then princes and princess underneath them. So that is a hierarchy. There is also a hierarchical relationship in our universe. The way that I think of this is in like a nesting doll. So with the largest doll being, of course, the universe. The universe is everything put together, guys. And the majority of the universe is just made up of dark matter. We measure this in light years, and the universe is still constantly expanding in an elliptical fashion. We can tell that it is expanding mathematically. We can watch it happening. We can even measure it. So inside of that nesting doll, we have, of course, our galaxies. We have hundreds of billions of visible galaxies that we can see using scopes like Hubble, the James Webb Telescope, which is coming along soon from NASA. Its launch has been pushed back to 2023 because of COVID, if you can believe that. And in these galaxies, we can see exoplanets, we can see additional solar systems forming in them, and we can see these galaxies, their structure, and they're forming all the time. Next are our solar systems. We are not the only solar system in the universe. Most likely, there are billions of other solar systems in the universe. As long as you have a large star, which is going to carry a lot of mass, it's going to have a gravitational pull, because gravitational pull is directly linked to mass. The 98% of the mass of our entire solar system is in the sun. So if you take everything else in our solar system, if you take all the planets and you add them up, they still will not equal the mass of our sun, which is 98% of the entire solar system's mass. We can see other solar systems mathematically, and I think that we're getting to the point very soon where we're going to actually be able to see into other solar systems and look at those planets directly. Now, underneath that, of course, we have our planets, our moons, and then also included in this part of the hierarchical relationship are things like asteroids, space rocks, and space debris. So these are things that are flying around in our solar systems that can go from quite large, of course, like our big gas giants, to quite small, and are even human-made. So when I'm talking about space debris, I'm talking about some of the things that we have out in space that maybe do not work anymore, satellites that we have up there, even on Mars, where we have rovers that are no longer functional. That is considered space debris. Okay? Now, I'm going to go ahead and go down to the bottom of the board, and I want to talk to you briefly, so briefly, because it's just like an introduction and keep on writing, about how solar systems actually form. This is also a hierarchical relationship in that the largest thing has to form first, and that is this solar nebula. What that means is a baby sun. And what's going to happen is there's actually going to be a collapse of that solar nebula. When it collapses, that means that enough of that mass has come in around a center that now you're going to have a glowing star, or a stellar disk. It's not a star in the fact that it is rotating and it is still trying to pull in to its center. It's still trying to begin to burn like a sun would, and it needs to begin to rotate and continue to pull all of that matter in and around a center. Okay, we're going to talk about that next week when we get to the law of universal gravitation. The next step in that relationship is that the formation of the sun or the star actually takes place. This can take billions of years to come all the way from the solar collapse to the formation of that sun or that star. This can be a very, very long process to go from number 1 to number 2. Now, what actually happens pretty close to that time period is what's called number 3, which is planetesimal formation. All right, so this is like baby planets. This is when the planets are starting to begin to form, and all that they really are clouds of dust that are beginning to gather again around a center and become much larger and move into a spherical shape. There's a reason why our planets are spherical. All those flat earthers out there, all we have to do is look through a telescope and we can clearly see that the planets are spherical. Our moon is spherical. Well, the reason why it's spherical is because those planetesimal formations are going to form around a center. Then lastly, planets are going to actually begin to form. They're going to take their final form either as a terrestrial planet or as a gas giant. They're going to gain a great deal of mass or weight, and that weight is going to result in increased gravitational pull. We're going to talk a little bit on the next board about our terrestrial planets and our gas giants. So I'll see you guys on board 2. Okay guys, this is a blank board 2. The reason why it's blank is because I'm going to have you guys fill it out while I do the actual instruction on it. And what you're doing is adding 2 to 3 of the most important bits of information to each part of this chart, and you're going to be writing it in your ISN. Okay?